All right, in this video, we're going to talk about section 5.2, dealing with systems of linear equations in three variables. And in this video, we're going to verify the solution of a system of linear equations in three variables. That means we'll take an ordered triple and verify that that ordered triple is a solution to that system of linear equations in three variables. Also, we're going to solve systems of linear equations in three variables as well. All right, so let's start with what a system of linear equations in three variables and what their solutions are. In general, any equation of the form ax plus by plus c equal to d, where a, b, c, and d are real numbers such that a, b, and c are all not zero. It is a linear equation in three variables, x, y, and z. So if you recall, you were pretty much solving a system of linear equations in two variables, mainly x and y. But this time, it's going to be in three variables, x, y, and z. And the solution of a system of linear equations in three variables is an ordered triple of real numbers that satisfy all equations of the system. Okay, so for a system of linear equations in two variables, you were looking for a ordered pair. This time, with three variables, you're going to be looking for an ordered triple that will satisfy all the equations in that system. Here, the solution set of the system is a set of all of its solutions. So let's start off with example number 1. In this case here, we want to show that the ordered triple, -1, -4, 5 is a solution of the system. So in this case here, we need to verify all three variables by substituting the x, y, and z with those values. So in this case, our ordered triple was -1, -4, and 5. What that means is this: it's in the form x, y, and z, where x is equal to -1 and y is equal to -4, z is equal to 5. Okay, so we're going to substitute these values in each of these equations. Okay, and this ordered triple must satisfy all three in order for it to be a solution for the system. Otherwise, it's not going to be a solution to that system. So let's start with the first equation: x minus 2y plus 3z is equal to 22. All right. Now in this case, your x is -1, the y is -4, z is 5. Here we just substitute into that system. So in this case, your x, we replace that with -1, minus 2 times the y is being replaced with -4, plus 3 times z, which is 5. I want to know if that left side, if I simplify it, it should equal to 22. All right, so here the -1, I just removed that out of the parentheses. -2 times, well, minus 2 times the -4 will be a plus 8. And then plus 3 times 5, which is 15. I want to know if that's equal to 22. Now I'm going to simplify from left to right. If I add -1 to 8, you're going to get 7. And then if I add 7 and 15 together, I should get 22. And I do get 22. So here, this is true for only the first equation. I also got to do the same thing for the second and the third equation. All right. Now, my second equation in that system is the 2x minus 3y minus z equal to 5. Again, I'm going to replace the x with -1, the y with -4, and the z with 5. So this will be 2 times x is -1, minus 3 times y, which is -4, minus z, which is 5, that should equal to 5 when I simplify the left-hand side. So 2 times -1 would be -2. Minus 3 times that -4 will be a plus 12. And then minus 5, that should equal to 5. Now let's simplify from left to right. -2 plus 12 will be 10. And if I subtract 5 from 10, I should get 5. And in this case, I do. So here, that ordered triple is true for the second equation. So I found that it's true for the first and the second. I also have to do the third as well for that ordered triple to be a solution to the entire system. So that third equation in that system would be 3x plus y minus 5z equal -32. Now we just replace the x with -1, the y with -4, and the z with 5. So here I'm going to have 3 times x is -1 plus y, which is -4, minus 5 times z, which is 5. That should equal to -32. And now 3 times -1 would be -3 plus -4. Minus 5 times 5 would be a minus 25. That should equal to -32. Now, if I add -3 and -4 together, I'm going to get -7. And if I do -7 minus 25, that is the same as saying -7 plus -25, which is -32. And that does equal to -32. So this is true. So you can see that this ordered triple is true for all 3 equations. So I can say here that the ordered triple -1, -4, and 5 is a solution to the system. Okay, so that's how we determine whether or not an ordered triple is a solution to the system. All right, now let's go into solving systems of linear equations of 3 variables. And we're going to do this by eliminating variables. Okay, so here, the method of solving a system of linear equations in 3 variables is similar to that used on systems of linear equations in 2 variables. Here we're going to use addition to eliminate any variable, reducing the system to 2 equations in 2 variables. Once we obtain a system of 2 equations in 2 variables, we use addition or subtraction to eliminate a variable. The result is a single equation in 1 variable. We solve this equation to get the value of the remaining variable. Other variable values are going to be found by using back substitution. Okay. So on the next page, as you'll see, is the method of solving a system of linear equations in 3 variables. And we're going to be eliminating variables as a method to solve a system of linear equations in 3 variables. First step is to reduce the system to 2 equations in 2 variables. This is usually accomplished by taking 2 different pairs of equations and using the addition method to eliminate the same variable from both pairs. Then the second step would be to solve the resulting system of 2 equations in 2 variables using addition or substitution. The result is an equation in 1 variable that gives the value of that variable. And then in step number 3, you're going to back substitute the value of the variable found in step 2 into either of the equations in 2 variables to find the value of the second variable. And then step number 4 would be to use the values of the 2 variables from steps 2 and 3 to find the value of the third variable by back substituting into one of the original equations. And then step number 5 would be to check your proposed solution in each of the original equations. Okay. Now, let me go ahead and go into this example here, solving a system of equations in 3 variables using this method or this procedure. All right, let's say in this example number 2, we're going to solve the system. Here we got x plus 4y minus z is equal to 20. 3x plus 2y plus z is equal to 8. 2x minus 3y plus 2z is equal to negative 16. And we're going to solve this system of linear equations in 3 variables by eliminating variables here. The first thing I'm going to do here is label my equations that I have here. All right, so that first equation here, I'm going to label that as equation 1. The second equation, I'm going to label that as equation 2. And then the third one, equation 3. Okay. Now here I can pick any 2 variables and then, any 2 equations and then eliminate a variable. But then I had to pick another pair of equations and eliminate that same variable, because the objective here is I want to reduce this to having 2 equations with the same 2 variables. All right, so to begin with, and this is just by me looking at this system of equations here, 3 variables, notice the first equation, the second equation. I have a minus z and a plus z. I can easily eliminate that. So I'm going to use equation 1 and equation 2 to eliminate a z, the z here. So in equation 1, that was x plus 4y minus z equals 20. And the second equation was 3x plus 2y plus z is equal to 8. Now, sometimes they call the addition method the elimination method. And that's because you're trying to eliminate a variable. And in this case, by looking at this, I can eliminate a z because I have minus z and a plus z. That is eliminated. That I can eliminate and then add the 2 equations together. X plus 3x, or 1x plus 3x, that will be 4x, plus, I'm going to label that equation 2, 4y plus 2y, that's 6y, and that's equal to 20 plus 8. That will be 28. Okay. And I'm going to label this equation 4. Okay. Because I got equation 1, equation 2, and equation 3. This new equation that I came up with, I'll label that as equation 4. All right, now I'm going to pick another pair of equations and try to eliminate the z as well, because that next equation, I'm going to pair that with equation 4 and try to do the elimination method again to get it down to an equation with a single variable. Well, I've already used 1 and 2. Let's try to use equation 2 and 3. Okay. I could use 1 and 3, but let's go ahead and use 2 and 3 here. Well, let's do this. I'll use 1 and 3 because notice I have a minus z and a plus z. I'm going to use those to eliminate the z's. All right, so my equation 1 is that x plus 4y minus z is equal to 20, and that's a z, by the way. And then the third equation is 2x minus 3y plus 2z equal negative 16. All right, now for me to eliminate a z, because I want to pair that fifth equation, that new equation with equation 4, I need to make that minus z minus 2z. And to do that, I need to multiply that top equation by 2. Okay, if you recall, when you're using the elimination method with the system of linear equations in 2 variables, sometimes you may have to multiply either the first equation or both equations by some number to make the variables the same so that you can eliminate those. And in this case here, I have to multiply the top equation by 2 in order for me to eliminate a z, because I need a 2z in that first equation. So when I do that, 2 times x, that's going to give me 2x. 2 times a plus 4y will be a plus 8y, minus 2 times z, which will be 2z, and that's equal to 2 times 20, which is 40. And then I'm going to bring over equation 3, which is at 2x minus 3y plus 2z equal negative 16. Now I'm going to add those 2 equations together to come up with equation 5. Okay. Now notice I got minus 2z and a plus 2z. That's gone. So when I add 2x plus another 2x, that's 4x. 8y minus 3y would be a plus 5y. That's equal to 40 minus 16 would be 24. So now notice I have equation 4 and equation 5 as equations in only 2 variables. Okay, so now I'm going to use those 2 equations and use the addition method and come up with an equation in a single variable that will give me the value of that variable. So all of what I did here was step number 1. So now here's step number 2. I'm going to take equation 4 and 5, which is in this case, equation 4 is 4x plus 6y equals 28. The second equation is 4x plus 5y equal 24. Now, what I need to do here is I can go ahead and eliminate the x's because I got 4x to the 4x, but they're both positive. For me to eliminate an x, one has to be positive, the other one has to be negative. I'm going to make equation 5 negative by multiplying that equation 5 by negative 1. I could multiply equation 4 by negative 1 if I wanted to, but one of them has to be a positive, the other one has to be negative in order for me to eliminate. So that equation 4, I'll rewrite that as 4x plus 6y equals 28. But when I multiply equation 5 by negative 1, that'd be negative 1 times 4x, that's a negative 4x. Negative 1 times a plus 5y will be minus 5y, equaling to negative 1 times 24, negative 24. Now I can add those 2 equations together. And what's going to happen here is the negative 4x and the plus 4x, they're gone. So now, adding these 2, 6y and the negative 5y will be 1y, or just y, is equal to 28 plus negative 4 will be 4. So I know one of my values here in this ordered triple would be 4. So I know y is going to be equal to 4. Now I need to find out what x is, and I need to find out what z is. Let's see here. Since I got these 2 equations, equations 4 and 5, in terms of x and y, let's find out what x is. Now I can use either one of these 2 equations here. So let's see here. I'm going to use equation 4. Does not matter which one I use. Using equation 4, which is the 4x plus 6y equals 28. Since I know y is equal to 4, I can substitute the y with the 4 and find out what x is. So here I'm going to have 4x plus 6 times the y is 4, that's equal to 28. Okay, and then 6 times 4 is 24, so I have 4x plus 24 is equal to 28. And then to get 4x by itself, I'm adding 4, so I'm adding 24, so I need to subtract 24 on both sides. That will give me 4x is equal to 4. And to solve for x, I'm multiplying by 4, so I need to divide both sides by 4. That will tell me that x is equal to 1. Okay? So that means the x coordinate here is going to be 1. I know what x is. Now I know what y is. Now I need to find out what z is going to be equal to. So that means I need to use one of the 3 original equations and substitute the x and the y into one of those 3 equations. Now in this case here, I'm going to go ahead and use equation 1. And equation 1 is this, that x plus 4y minus z is equal to 20. I'll go ahead and write that down. I'm going to substitute the x with 1 and the y with 4 in that first equation. So x will be 1 plus 4 times y, which is 4, minus z is equal to 20. Now, 4 times 4 will be 16, so this will be 1 plus 16 minus z is equal to 20. Add 1 and 16 together, you'll get 17. So it'll be 17 minus z is equal to 20. And then to get that minus z by itself, we're going to subtract 17 on both sides. This will give you negative z is equal to 3. But we got the negative in front, so let's go ahead and divide both sides by negative 1. So positive z will be equal to 3 divided by negative 1 would be negative 3. So here at the very top is the solution to that system of linear equations in 3 variables, 1, 4, negative 3. And of course, I'll leave the check up to you. That means you just substitute the 1, the 4, and the negative 3 for x, y, and z respectively in each equation. The left side should equal to the right side. Okay. All right, now here's another example. All right, let's say I want to solve this system. Notice I get 2y minus z is equal to 7. And then x plus 2y plus z is equal to 17. 2x minus 3y plus 2z is equal to negative 1. And here I want to solve this system of linear equations in 3 variables. Okay. Notice something here. This first equation is already in 2 variables. In this case, y and z. Let's work with these 2 equations down here at the bottom. Okay, so this first equation, I'll label these as equation 1. The first equation, equation 1. Second equation, equation 2. The third equation, equation 3. Let's work on equations 2 and 3 and reduce that so that I'll have an equation with only a y and a z. Okay, it's better to do it that way because I've already got that first equation in terms of y and z. Let's use these 2 equations and reduce that to be in terms of y and z. And then we can find out what the value of one of the variables is using the addition or elimination method. So here, my second equation is this. The second equation is x plus 2y plus z is equal to 17. The third equation is 2x minus 3y plus 2z equals -1. Okay. Since that first equation is in terms of y and z, let's eliminate the x in equations 2 and 3. Well, I got a 2x right here, but I want to make that x -2x. Well, to do that, I need to multiply the top equation for equation 2 by -2. And when I do that, -2 times x would give me -2x. -2 times a plus 2y would be a -4y. -2 times a plus z would be -2z. And that's equal to -2 times 17, -34. And then bring down the 2x minus 3y plus 2z is equal to -1. I'm just rewriting equation 3 over. And now you can see here, by use the addition method, -2x and plus 2x, that's gone, added together. -4y and a -3y is a -7y. And also notice something else. -2z and a plus 2z. Guess what? That 2 is gone. On we lucky. And then that's going to be equal to -34 plus -1 would be -35. So now, guess what? I have an equation in a single variable. -7y equals -35. So now to solve for y, we just divide both sides of this equation by -7. That will give you y is equal to 5. So guess what? I know what my y coordinate is going to be for this ordered triple. It's going to be 5. All right. Let's find out what z is going to be. Notice in equation 1, this is in terms of y and z. And I found out what y is. Let's find out what z is using equation number 1. And equation number 1 was 2y minus z is equal to 7. And y is equal to 5. So let's replace that y with 5. So it'd be 2 times 5 minus z equals 7. And then 2 times 5 in this case would be 10 minus z equals 7. And then to get that minus z by itself, I need to subtract 10 on both sides. So here, minus z is equal to 7 minus 10 would be -3. And to get rid of the minus sign, the negative sign in front of the z, so that we can solve a positive z, we need to divide both sides by -1. Or you could multiply both sides by -1 the same. Either way, you're going to get z is equal to 3. So I know what x is, and I know what y is 5, and z is 3. Let's find out what x is. And it would be best to use either the second equation or the third equation in the original system. Won't help us to use the first equation. It'd be best to use either the second or the third equation. And I'm going to use equation 2. And equation 2 was x plus 2y plus z is equal to 17. So we replace the y with 5 and the z with 3. So here's what I'm going to have. X plus 2 times y, which is 5, plus z, which is 3, equals 17. And then x plus 2 times 5 will be 10 plus 3 is equal to 17. Add 10 and 3 together, you'll get 13. So the x plus 13 equals 17. And then to get the x by itself, we're adding 13. You need to subtract 13 on both sides to get x is equal to 4. So here, x is 4, y is 5, and z is 3. So this is the solution to that system of linear equations in 3 variables, 4, 5, 3. All right, now let's look at the next example. Let's say we have something like this. And look at how that system of equations in 3 variables look like. Here we got 3 times the quantity 2x plus y plus 5z is equal to -1. 2 times the quantity x minus 3y plus 4z is equal to -9. And 4 times the quantity 1 plus x is equal to -3 times the quantity z minus 3y. All right, let's simplify these equations here before we start trying to simplify using the addition or the elimination method. All right, that first equation, well, I can label this as equation 1, equation 2, and equation 3 if I like. So starting with that first equation, here I got 3 times the quantity 2x plus y plus 5z is equal to -1. Let's simplify this in a way so that the x and the y and the z are on one side and the constant terms on the other side. Well, that constant term is on the other side, but let's simplify the left side. Use the distributive property. This will be 3 times 2x, that's 6x, plus 3 times y, which is 3y, plus 5z equals -1. Okay. And that will be as far as we can go with that problem here, because notice the x, the y, and the z on the left side, the constant term is on the other side. Now, equation 2 is this: 2 times the quantity x minus 3y plus 4z equals -9. Now, in this case, if we use the distributive property by distributing the 2 over everything in the parentheses, 2 times x is 2x, minus 2 times 3y, which is 6y, plus 2 times 4z, which is 8z. That's equal to -9. Notice we have the x and the y and the z terms on the left side. The constant term is on the other side. All right, now equation 3 is a little bit complicated. Here we got 4 times the quantity 1 plus x equals -3 times the quantity x minus 3y. All right, so now let's use the distributive property on both sides of the equation first. 4 times 1 will be 4, plus 4 times x will be 4x. That'll be equal to, if I take the -3 multiplied by x of -3x, -3 times a -3y will be a plus 9y. Now we need to move terms in a way so that all of the x, y, and z terms on the left side and the constant terms on the other side, just like these, the equation 1 and equation 2. Okay, here's what I'm gonna do. I'm gonna bring down that 4x. If I move the minus 3x over to the opposite side of the equation, it becomes plus 3x. If I move the minus 9y over to the opposite side, if I move the plus 9y over to the opposite side, it's going to be a minus 9. I think I made a mistake here. That should not be an x. This should be a z. It should also be a z as well. I'm going to white out all of this here. Okay. All right, that should be at 4 plus 4x, and then that's equal to negative 3x plus, negative 3z plus 9y. Okay, got the 4x on the left side. Let's move the plus 9y over to the opposite side. That will be a minus 9y. And then the minus 3z, if I move that over to the opposite side, that would be a plus 3z. That's equal to, now the constant term is the 4. If I move that over to the right side, it's going to be negative 4. Okay. So here I'm just manipulating terms over to the opposite side in a way so that the x, y, and z are on one side, the constant term is on the other side. So these are my new equations for this system. Equation 1 is this: 6x plus 3y plus 5z equals negative 1. Equation 2, 2x minus 6y plus 8z equals negative 9. Equation 3 is 4x minus 9y plus 3z equals negative 4. These are my new equations where all the x's are x, y, and z's are on one side and the constant term is on the other side. Okay, so now let's work with a couple of equations where we can eliminate either an x or a y or z. I'm going to look at equations 1 and 2 because notice I have a plus 3y and a minus 6y. Let's try to eliminate the y's here. So equation 1 is this: 6x plus 3y plus 5z equal negative 1. Equation 2 was 2x minus 6y plus 8z equal negative 9. And I'm going to try to eliminate the y because I know I got plus and a minus sign here. Well, if I want that 3y to be 6y, I need to multiply that equation number 1 by 2. And when I do that, here's what I'm going to have. 2 times 6x, that's 12x, plus 2 times 3y, which is 6y, plus 2 times 5z, which is 10z. That's equal to 2 times a negative 1, which will be negative 2. The second equation, equation 2, I'll just bring that over. 2x minus 6y plus 8z equals negative 9. And I'm going to add those two equations together. So here, 6y and a minus 6y, that's gone. And now if I add the two equations together, 12x and 2x, that's 14x. 10z plus 8z will be plus 18z, equaling to negative 2 plus 9 will be negative 11. Okay. And I'm going to label this as equation number 4. Okay. Now I need an equation 5 so I can work with equation 4. Let's see here. I'm going to try equation 1 and equation 3 and eliminate the y as well, okay? Because they got a plus 3y and a minus 9y. So let's use equations 1 and equation 3. Equation 1 again is the 6x plus 3y plus 5z is equal to -1. Equation 3 was 4x minus 9y plus 3z is equal to -4. Well, I've already got the minus and the plus here, but let's make the 3y 9y. And to do that, I need to multiply equation number 1 by 3. Now, when I do that, here's what I'm going to have. 3 times 6x, that's going to be 18x. And then plus 3 times 3y, which is 9y, plus 3 times 5z, which is 15z, equaling to 3 times -1, which will be -3. And now I'll bring over equation number 3, which 4x minus 9y plus 3z equals -4. And now in this case here, you're going to see that the 9y, the plus 9y, and minus 9y, that adds to 0. They're gone. Now if I add 18x and 4x together, you'll get 22x. Plus 15z plus 3z is 18z equals -3 plus 4 would be -7. And I'm going to label that equation as equation 5. Okay. Now, equations 4 and equation 5 are equations that are in terms of x and z. Let's use those and either eliminate the x or the z. Okay. So equation 4, I came up with 14x plus 18z equals -11. Equation 5, I came up with 22x plus 18z equals -7. Well, this is going to be quite easy because notice I got 18z and 18z, but one of them needs to be a plus, the other one has to be a minus. So what I will do here, and it doesn't matter which one you use, I'm going to use the first equation 4 and multiply equation 4 by -1. So in this case, -1 times 14x will be -14x or -14x. -1 times the 18z will be -18z equals minus -1 times the -11 would be a +11. And then I'm going to write equation 5 over, because as you will see, when I add -18z and a plus 18z, that gives me a sum of 0. And I'll have an equation in a single variable. Add -14x and 22x, you're going to get 8x, equaling to 11 plus -7 would be 4. So 8x will be equal to -4. And if you divide both sides by 8, this will be a fraction. X will be equal to 4 over 8, but it does reduce to 1/2 in simplest form. So X will be equal to 1/2. So I know what X is. I can find out, in this case, what Z is going to be, since I have equations 4 and 5, which are in 2 variables. All right, I know what X is. Let's find out what Z is. I can use either equation 4 or equation 5. Here I'm going to go ahead and use equation 4. So using equation 4, which is in this case 14x plus 18z equals negative 11. I'm going to replace the x with 1/2. So this will be 14 times x, which is 1/2, plus 18z equals negative 11. Well, 1/2 of 14 would be 7, so I'll have 7 plus 18z equals negative 11. Now, if I subtract 7 on both sides, I'm going to get 18z is equal to negative 18. That's negative 11 minus 7. And then divide both sides by 18. That means z is equal to negative 1. Well, x is 1/2, z is negative 1. Now I need to find out what y is. Well, to find out what y is, I need to go back to one of my original equations, and I'm not going to be using these up here. I'm going to be using these right here. These are the ones that I use here because they're more simplified. So using the simplified equation number 1, and that simplified equation number 1 was 6x plus 3y plus 5z is equal to negative 1. I'm going to replace the x with 1/2 and the z with negative 1. So here, this will be 6 times x, which is 1/2, plus 3y plus 5 times z, which is negative 1, equals negative 1. Now, if I simplify that equation, 1/2 of 6 will be 3. So it'll be 3 plus 3y. And then plus 5 times that negative 1 would be minus 5. Now it'll be equal to negative 1. And then next I have 3y. Now if I do 3 minus 5, 3 minus 5 will be negative 2. So it'll be 3y minus 2 equaling to negative 1. And to get 3y by itself, I'll add 2 to both sides. So that means 3y is equal to negative 1 plus 2 will be 1. Divide both sides by 3. You'll get y is equal to, and this will be a fraction as well, 1/3. So the solution for this system of linear equations in 3 variables will be the ordered triple. Here, x is 1/2, y is 1/3, z is negative 1. Okay. So that's how we solve that system of equations there. Okay. All right, and finally, I have one more example. Let's say a system of equations in 3 variables was written like this. X plus 2 divided by 6 minus y plus 4 divided by 3 plus z divided by 2 is equal to 0. Second equation, x plus 1 divided by 2 plus y minus 1 divided by 2 minus z divided by 4 is equal to 9/2. The third equation, x minus 5 divided by 4 plus y plus 1 divided by 3 plus z minus 2 divided by 2 is equal to 19/4. Okay, we need to simplify this a bit. Okay. So if you want to, you can label these as equations 1 for the first one. This one, equation 2, this one, equation 3. But we're going to simplify these equations here before we start solving for x, y, and z. All right, let's start with the x plus 2, the first equation. X plus 2 divided by 6 minus y plus 4 divided by 3 plus z divided by 2, and that's equal to 0. Now, we got numerical terms in the denominator. Let's get rid of those by finding the least common denominator for 6, 3, and 2. And in this case, it's going to be 6. So what I'm going to do here is multiply each and every term in that equation by 6. Because I know 6 is divisible by itself, 6 is divisible by 3, and 6 is divisible by 2. As I'm using the smallest multiple that is divisible by all 3 numbers in the denominator. Okay. Now, when I simplify this, these 6's divide out in that first term. I'm left with x plus 2 minus, and if I divide the 3 into this 6, that's going to go 2 times. So I'm going to end up with 2 times the quantity y plus 4 plus, for this term right here, if I divide 2 into 6, that's going to go 3 times. So this will be 3 times z, or 3z. That's equal to 6 times 0, which is 0. Now let's simplify the left-hand side. Bring down this x plus 2. And if I do minus 2 times the y, that's going to be minus 2y. And if I do minus 2 times the plus 4, that's going to be minus 8. And then plus 3z is equal to 0. Now let's see here. I'm going to write the variables first, x and then minus 2y, and then plus 3z, and do 2 minus 8, which is of course negative 6. 2 minus 8, that's negative 6. Now I want that constant term to be on the other side. So if I move that minus 6 over to the opposite side, it's going to be a plus 6. Or think of this as adding 6 to both sides, if you choose. So this would be x minus 2y plus 3z equals 6. So that's my new equation 1. Now let's look at equation 2. Here we got x plus 1 divided by 2 plus y minus 1 divided by 2 minus z divided by 4. That's equal to 9/2. Now in this case here, I need to find a least common denominator for 2 and 4. Smallest multiple that goes into, that is divisible by 2 and by 4. It'll have to be 4. So what I'm going to do here is multiply each and every term in this equation by 4. As you can see, 4 will be multiplied by each and every term here. That's actually a z there. Now, when I simplify this, if I divide this 2 into the 4, that's going to go 2 times. So this will be 2 times the quantity x plus 1 plus, again, 2 goes in the 4 2 times. So I have 2 times the quantity y minus 1. And then minus, of course, the 4's divide out. I'm left with a z. By the way, let me go ahead and make that z look like a z. Then that's equal to, divide 2 into 4, that's going to go 2 times. Then if I multiply the 2 times that 9, I'm going to get 18. So here I have an equation without fractions in them. Now let's simplify the left side. If I do 2 times x, that's 2x, plus 2 times 1, which will be 2, plus 2 times y will be 2y, And then minus 2 times 1 will be 2. And then minus z, that'd be equal to 18. Let me write all the terms that have x, y, and z in it first. Bring down the 2x plus 2y minus z. 2 minus 2, that's 0. And I'll be left with equals 18. So here I got 2x plus 2y minus z is equal to 18. That's going to be the new equation 2. Okay, now equation 3. Okay, let me bring this down, bring this paper down. I'm going to write down equation 3. That's x minus 5 divided by 4 plus y plus 1 divided by 3 plus z minus 2 divided by 2 equals 19/4. Now I need to find the least common denominator for 4, 3, and 12. 4, 3, and 2. And I think I already gave it away. It's going to be 12 because 12 is divisible by 4 and by 3 and by 2. So I'm going to be multiplying each and every term in equation 3 by 12. All right, now I'm going to simplify all of this. Let's see, 12, well, 4 goes into 12 3 times. So I'm going to have 3 times the quantity x minus 5 plus, if I divide 3 into 12, that goes 4 times. So it'll be 4 times the quantity y plus 1 plus, divide that 2 into 12, that goes 6 times. That would be 6 times the quantity z minus 2. That's equal to, let's divide 4 into 12. That's going to go 3 times. 3 times the 19 will give me 57. And then if I use the distributive property and combine like terms on the left side of this equation, 3 times x will be 3x, minus 3 times 5, that'll be 15, plus 4 times y will be 4y, plus 4 times 1 will be 4, plus 6 times z is 6z, minus 6 times 2 is 12. All that equals 57. All right, and now we're going to go ahead and bring down these x, y, and z and combine like terms. I'm going to bring down the 3x, and then the plus 4y, then the plus 6z. Now, if I do 15 minus 4, that's going to be, negative 15 plus 4, that would be negative 11. Negative 11 and minus 12 would be minus 23. That's equal to 57. And then I'll add 23 on both sides because I only want the x, y, and z on one side and the constant terms on the other side. So here I'm going to have 3x plus 4y plus 6z is equal to 80. Okay, so these are my 3 simplified equations. And I'm going to go ahead and write this on a separate sheet of paper here. Equation 1 was x minus 2y plus 3z is equal to 6. The second equation was 2x plus 2y minus z is equal to 18. And then the third equation, the new equation 3, is 3x plus 4y plus 6z is equal to 80. These are my three new equations here. And if you need to, feel free to pause this video so that way you can get caught up with what I've written so far. Okay. So these are my three equations here. Let me move this paper out the way. All right, so now let's work with these and eliminate either an X or Y or Z. And what I did in this case was eliminate the X's. I combine equation 1 and equation 2 and eliminate the X's here. So let's use that. All right, so equation 1, of course, is X minus. And you know what I could do? Let's use equations 1 and 2. Because notice I got a minus 2y and a plus 2y. Let's go ahead and wipe out those y's. So I get X minus 2y plus 3z is equal to 6. That's equation 1. Equation 2 is 2x plus 2y minus z is equal to 18. Now I'm just going to go ahead and straight add those two equations together, because notice the minus 2y and the plus 2y, they're gone. I can eliminate that. So now I got 1x and a 2x, that's 3x. 3z minus 1z will be a plus 2z equals 6 plus 18 will be 24. This will be my new equation 4. And then next I'm going to use, well, I use equations 1 and 2. Let's use equations 1 and 3 to get another equation in terms of x and z and eliminate the y. So my equation 1, of course, is that x minus 2y plus 3z is equal to 6. Equation 3 is 3x plus 4y plus 6z is equal to 80. Now, I have a minus and a plus here, but if I want the minus 2y to be minus 4y, I need to multiply that top equation by 2. And when I do that, this is what I will get for equation 1. 2 times x, that's 2x, minus 2 times y will be 4y, plus 2 times 3z, which is 6z, that's equal to 2 times 6, which is 12. And then I'll copy over equation 3, which is 3x plus 4y plus 6z is equal to 80. And notice that minus 4y and the plus 4y, they're gone. So I'm going to be left with this. 2x and 3x added together will be 5x. Plus 6z plus another 6z is 12z. And then 12 plus 80 will be 92. So this is going to be equation 5. So I'm going to put equation 4 and 5 together. Equation 4 was 3x plus 2z is equal to 24. Equation 5 was 5x plus 12z is equal to 92. Okay. And you know what I'm going to do here? I'm going to eliminate a z, because I know I can multiply that 2z by some multiple to get 12z. So if I want that 2z to become 12z, and I have to make it negative, by the way, since both of them are positive, I have to multiply that top equation by -6. And this is what I would get. when I multiply equation 4 by -6. -6 times 3x is -18x. -6 times 12z will be -6 times 2z will be a minus 12z. And then -6 times 24. Okay. Give me my calculator. -6 times 24, that's -144. And then bring over that 5x plus 12z is equal to 92. And I'm going to add those two equations together. Add equations 4 and 5 together. Minus 12z and the plus 12z, they're gone. -18x and 5x will be -13x. And then that's equal to -144 plus 92 would be -52. So I got -13x is equal to -52. Divide both sides by -13. You'll end up with x is equal to 4. So I know what x is. That's going to be equal to 4. Now I need to find out, in this case here, since I got these equations in two variables, I know what x is. I need to find out what z is. Okay. I'll use equation 5. Doesn't matter which one to use. I can use either equation 4 or 5, but I'm going to use equation 5, which is, of course, 5x plus 12z is equal to 92. And we'll replace the x with 4. So it'll be 5 times 4 plus 12z is equal to 92. 5 times 4 will be 20 plus 12z equals 92. And to get 12z by itself, I'm going to subtract 20 on both sides. So this will be 12z is equal to 72. Divide both sides by 12, you'll get z is equal to 6. Okay, so I know what x is and I know what z is. Now I need to find out what y is going to be equal to. And this is where I need to use one of these 3 simplified equations to find out what y is. Let's use that first equation. So I'm going to say using equation 1, and equation 1 was x minus 2y plus 3z is equal to 6. Okay. So now I'm going to replace the x with 4 and the z with 6. So x is 4, so that'll be 4 minus 2y plus 3 times that z is 6 is equal to 6. And bring down the 4 minus 2y and multiply 3 times 6, which is 18. That's equal to 6. Add 4 and 18 together, you'll get 22. So I have -2y plus 22 is equal to 6. And then to get -2y by itself, I have to subtract 22 on both sides. So that's going to give me -2y is equal to -16. And then divide both sides by -2. You'll get y is equal to +8. Okay, so we got x, y, and z. So that means that the solution to this system of linear equations in 3 variables will be x comes first, that's 4, and then y, which is 8, and then z, which is 6. So 4, 8, 6 is the solution to that linear system in 3 variables. Okay, so that will conclude this video on section 5.2, dealing with system of linear equations in 3 variables. Do watch this video as much as you need to, and also there are homework problems that are related to that. So try to do those, and feel free to contact me if you have any questions about this lesson.